All right, so I tried to make a video once and apparently it did not record. So we're going to go round two. So everything's already going to be written down for you guys. So today we're going to be solving by factoring. So for your bell work here, we're going to factor on this one. It's the factors of negative 14 to get 5. So the factors of negative 14 are 7 and negative 2. When I add it, I get the 5. If I multiply it, I get the negative 14. So that's why we just put a plus 7 here and a minus 2 there. So now remember on the next one, in order to get it, we have to multiply the 2 and the negative 20 and the negative 12 because it's the factors of multiplying that together. So it's factors of negative 24 that are going to add to get me to negative 5 here. So I went ahead and I got negative 3, negative 8, and a positive 3. So remember we bring down the negative 5 changes to negative 8 and a positive 3. Then I group the first 2 I pulled out of 2x. The second 2 I pulled out of 3. So now my factored answer is 2x plus 3 and x minus 4. The last one is the one where we do the square root. So I went ahead and I square rooted the 4x squared and I square rooted the 9. This is called a difference of squares. So then we do a plus between them and a minus between them. And so now they're factored. So our learning target today is that you can solve quadratic equations by factoring. So first, the solutions to a quadratic are called the zeros because they are the x values that make the equation equal to 0. So like if I plug it into the equation and you hit equals in your calculator, you should get out 0. They occur when y equals 0, or that's when the function will cross the y-axis, so we call them x-intercepts. So there's 3 different cases you can get. So I said that you could have one where it doesn't hit the axis. It could go up or it could go down. That's a no solution. Then one solution is that your vertex sits on the axis, like this picture right here. And then the last solution is when they actually hit twice. So that's what 2 solutions looks like. So we can solve quadratics by the rational zero theorem. So what that says is that if I'm multiplying 2 terms and it equals 0, then either A has to equal 0 or B has to equal 0. So the important part is that it has to equal 0. This rational theorem does not work if it's equal to 2 or 5. It's only a rational 0. So make sure it equals 0 first. So the problems from above, we use the same problems. So this is the same as what the bell work was above. So all I did was to take the answer from above up here, how we find this answer. And now the extra step is I have to set each parenthesis equal to 0. So I said x plus 7 equal to 0 and the x minus 2 is equal to 0. And then I need to solve. So I subtracted 7 from both sides and I added 2 to both sides. So the second question here is again the bell work. And so I just factored the same way we did above. So here's the factored answer. Now I need to set each part equal to 0. So I set the first parenthesis equal to 0 and the second parenthesis equal to 0 and solve. So here you just subtract 3 from both sides and then divide by 2. So negative 3 halves, or you can put negative 1.5 if you prefer. And then over here, just add your 4, so I get a positive 4. And then the last one again was the bell work, so we get 2x minus 3, 2x plus 3. So I set each parenthesis equal to 0. So this one and then that one. So solve each one. I add 3, divide by 2, subtract 3, divide by 2. And there are my solutions for that.